Hello, welcome back. Here is Ali Talabi, and this is lesson 3 from module 19. As I promised, today I'm going to talk about duration. So I will show you how to actually calculate the duration, and I will use an Excel example. Also, we'll talk more about the duration properties after I show you the example. So let's start our session. So, as we mentioned in the previous session, duration is based on the number of years, and also it is called the effective maturity for bonds. So, duration is showing the bond's effective maturity. So the one that you see on the bonds, for example, the 5-year bond, the actual effective maturity is shorter than 5 years, as long as you are not talking about the zero coupon bond, because for the zero coupon bond actually the duration is same as the maturity date. So if you have a 5-year zero coupon bond, the duration becomes the same 5 years, because you won't receive any cash flow, you won't receive any coupon payment until expiry date. However, for the coupon bond, which is usually the regular bonds we are talking about, the duration is shorter than the expiry date, and it is equal to the weighted average of the individual maturities of all the bonds cash flows. And the weights, remember, are proportionate to the present values of each cash flow. Now, to explain this concept, what we mean by the weighted average, it's better to look at the example. So here I'm going to show you an example how we can calculate the Macaulay's duration. So let's look at this example. Here is the example I mentioned. So let's look at this. You have the bond which is going to expire in 30 years. So the years to maturity is 30 years. The coupon rate is 10%. The face value is $1,000. So you will receive $1,000 30 years from now. And let's assume your yield to maturity or discount rate is 12%. So before moving forward, remember this is the coupon bond, so you will receive 10% on annual basis. Let's assume this is the annual coupon bond. Most of times, normally the bonds are paying coupons on semi-annual basis. But just to make it simple, let's go with annual basis, which means every year you will receive 10% of $1,000, which is $100. So as you see, year one, you will receive 10% of $1,000, $100. This is the same for all the following 30 years. So you will receive 30 equal payments of $100. So if I scroll down, you will see that you will receive $100 for the next 30 years. And finally, when it comes to expiry date, you will receive the face value or the par value of the bond, which is $1,000. So for the last year, year 30, you will receive $1,100, $1,000 because of the face value, and $100 because of the last coupon payment. So these are 4 major steps you need to follow to calculate the duration. In the first step, you need to calculate the present value of all these future cash flows. And the rate or the discount rate we are using, that's the YTM. And we know how to do that. Just find the present value of all these future cash flows. So please go back to time value of money concept if you have some challenges to calculate the present value. We are here just using the present value formula, which is the cash flow divided by 1 plus discount rate to the power of t, or the number of periods. For example, for the first one, as you see, you have $100, so I'm dividing that $100 by 1 plus the discount rate, which is 12%, to power of that period. 1, it's the discount period which I'm using here for the first payment. So the first payment $100, the present value is $89.28 almost. When it comes to the second year, you need to discount back for 2 periods. So as you see, I'm using A9 here, which is 2. So I'm discounting back for 2 periods with the annual rate of 12%. So you can calculate the present value of all these cash flows using this formula. That's the first step. The next step, you need to find the proportion of the present value of the cash flow to the bond price. Maybe you say, Ali, what is the bond price? Remember, we mentioned the bond price is the present value of all the future cash flows. In other words, if I add all the numbers I calculated in the first step, actually this gives me the bond price. So that's what I'm doing at the end of year 30. So that's a bond price. How I got that? Simply I added all the present values of the cash flows. Another way is to use your financial calculator. So we discussed this in module 6 and we learned how to calculate the bond price using the financial calculator. But since you're using the Excel file, this is already available. Just add all the present values of cash flows and find the bond price. In my case is almost $839. So as I mentioned, in the second step, just divide the present value of cash flows to the bond price, which in this case is $839 almost. So that's the second step. So far, so good, yes? The third step, you need to include the time factor, because we know that each year you receive different number and the value of this number is changing. Now, this is interesting. For duration, you have to include the value of the time, and as you're talking about a longer period of time, the effect of time is becoming more important. In other words, you have to multiply the t by the number you calculated in step 2. Present value cash flow divided by bond price times the t. For example, for the first year, you just multiply 1 by what you calculated from the second step, which is 0.106. So it gives you the same 0.106. When it comes to the second period or year 2, you will multiply year 2 by present value of the cash flow as a part of the bond price, and this gives you 0.190, and so on and so forth. So you go down and you just multiply the t or the year by what you calculated from step 2. And this is step 3. We are almost there. At the last step, just add up all these numbers you calculated in step 3, and that's the duration you were looking for. In our case, the duration or the effective maturity or expiry date of your bond is 9.16, which is much shorter than the 30 years expiry date. So that's a duration, and that's how we calculate that. Again, follow these 4 easy steps to find the duration of your bond. Now, let me provide you a few more notes before moving back to the slides and just looking at some final notes. I also I'm going to demonstrate the relationship between the YTM and the price for the example I provided. As we learn, as the YTM is going up, as the discount rate is going up, we learn that the bond price is going down. So now you can see in this example, what was the YTM be calculated? The YTM we had, it was 12%. For sure, if your discount rate is less than 12%, so the bond price will be higher. For example, if you use 10% discount rate, the 10% is same as the coupon rate, and we know in this case the bonds are sold at par, same as $1,000. As the discount rate is going down, the bond price is going up. So that's the first note I was going to mention. Now, I also created another table which you can see based on the changes in the coupon rate and YTM at the same time. The 839, that's the bond price. Now we can play with the bond price. We can play with the coupon rate and the YTM to see what's happening actually the bond price. As you see, as the coupon rate is going up, for the same YTM, the bond price is going up. For example, let's assume your YTM is just 1%. It's an imaginary wall, so we can play with all these numbers. So as the rate is 1%, the bond is sold at par, $1,000. The coupon rate goes to 2%. The bond price goes up to $1,258. So that's the case. Higher coupon rate, higher bond price. We had the argument as the YTM is going up, the bond price is going down. So for example, look at the 1% coupon rate. As you are moving down, it shows the YTM, the discount rate is going up, so the bond price is going down as well. And the last table I'm going to share with you is regarding the duration. So we talk about duration, and we learned the previous session that the coupon rate and the YTM impacts on the duration. For example, as you look at here, let's assume your YTM is 1%. As the coupon rate is going up, you see the duration is going down because you will get your money back faster. Higher coupon rate, it means you will get the bigger, higher amount of the coupon payment. But when it comes to YTM, you will see we have almost the same scenario. When, for example, for the 1% coupon rate, when the YTM is going up, also the duration is going down. That's the impact of the YTM on the duration. So you can play with these numbers and you can see what's implication on the duration. So let me go back to the slide. Let me just wrap up the session talking about the bonds durations properties, and then we'll end the session. So we learned that the longer bonds maturity, the longer its duration. So if you're comparing the, for example, 30-year bond to a 10-year bond, we know for sure that the 30-year bond has a longer duration. So that's for sure. And again, if we assume all other factors are constant, a bond duration increases at a decreasing rate as the maturity lengthens. So as the maturity is becoming longer, we understand that duration is also going up, however, at a decreasing rate. And remember, as the coupon rate is higher, the duration will be shorter, and we notice in the example I provided in the Excel file. And also we learned that as the yield to maturity is going up, we learned that the duration is going down. Also, we learned that in the Excel file I show you. And finally, the lower yield to maturity, it means the longer duration, which is actually the opposite of case number 4. Thank you very much. This is the end of this session. I hope you enjoyed this session. Have a wonderful day. Talk to you soon. Here is Ali Talabi. Stay safe, stay well.